Hey, here we go. We'll see how this works. Putting you in the... Looks like I'm recording. All right, guys, stand up. We are going to work off this board today and this board only because this is the only thing my camera can capture. Look at somebody and say, thanks for coming.
Thanks for coming.
And look at you guys right here. I say, thanks for coming. You better be watching this damn video. All right. Okay, sit back down. We have what due tonight. And some of you in video land are going to be like, oh crap, okay, when you hear that, because chances are it'll be beyond tonight. I still don't know about that quiz. I'm not going to hit it with you the Monday or the Tuesday after break. That just seems a little cruel. I want to make sure you get a break. Okay? I highly recommend taking work with you over break. Not that you'll do any of the work, okay? But when you're bored at home, okay? When you have your work and you can say, well, I'm tired of watching Netflix, well, I could do my work, and then you're not bored anymore. You're like, okay, I'll do something else. So yeah, it's an anti-boredom device. Your homework is an anti-boredom device. All right, where did we leave off last time?
We broke up the integral of tangents to 6x and secant to the 9th x.
Was that a good integral or a bad integral? And did we begin to realize why it was so bad and why we would never actually do that by hand? Okay, because you end up with a bunch of, once you do that, we'll call it Pascal's triangle. You expand that thing out, you end up having to use that reduction formula over and over and over again. So the way I kind of want to finish this section is, before we go to trig substitution, is I want to just derive one or two more reduction formulas because I do like putting these on the test. Okay, so I'll be here, and you guys are going to try to help me out with it. Okay, you guys are going to try to help me out. Imagine that I've got the integral, and this time I'm just going to keep it as n. Are you guys comfortable enough if I just keep it as a variable? I've got the integral of tangent to the n of x dx. And I'm asking, okay, how many people will look up there and say, that ain't a flashcard? How many, if you're looking at it, how many people are like, that ain't a flashcard? Okay, so you guys over here can't see people shaking their heads, but people are shaking their heads now, that ain't a flashcard. And we're like, okay, what could I possibly do to try to work with this? Use integration by parts, do something else. And you're like, well, Dr. Warren, you're kind of screwed at this point. And I'm not sure how long it would take you, but eventually you would think about it. It might take you 6 or 7 hours, okay, of pondering about it. But you might think, let's pull off a tangent squared. And so that's what I want you to do right now. And you in video land do the same thing. What I want you to do right now is pull off a tangent squared. Out of that, away from that tangent to the end. And you guys should be doing that at home too. Ria, you better be doing it. Okay, let's ask Gavin. Gavin, Gavin's not here. Gavin, you are here. Okay, what would you do? What did you say, Gavin? Oh, you would get a tangent to the, now you guys speak for Gavin. N minus 2 times x, and then times a tangent squared of x dx. How many people are with me? How many people are following? Okay, this one ends up being the easiest of all the reduction formulas. Tangent and cotangent end up being the easiest. We can actually get away with it not using integration by parts. What do I know is a trigonometric relationship between tangent and secant? And I want you guys to start getting this into your head. What's the trigonometric relationship? Think about that right triangle. What's the trigonometric relationship?
Secant squared minus 1, or is it 1 minus secant squared?
It's the hypotenuse is secant squared. So tangent squared plus 1 squared is secant squared. So it is secant squared minus 1. So make that substitution. And you guys at home, make that substitution. I'm checking your work too. Awesome. Okay, now I'm going to give you another step. Distribute, and break up those integrals. Okay, this may be a little harder today, but cheat, look off somebody. Declan, you're screwed. Okay, cheat, look off somebody. See if you've got the same thing that somebody else has.
Yeah, so we have the same thing.
Oh, okay.
Broke up the interval.
And you at home, you can cheat off of me. Not that I'm the best person to cheat off of, ask my old friends. Okay, how many people kind of match me? How many people are matching me at this point? Okay, now remember, it's called a what kind of formula again? It's all in the name.
Reduction.
We always go down by 2. We always go down by 2. And if we look here, we started with a tangent to the
And
and right here we have a tangent to the n minus 2. Now we stare at this a little bit, and if we can really think about it and look at it, it's not as hard as some of the other ones. What's the easiest integration technique other than flashcards? U substitution. Try to make a U sub. This guy's our reduction. Try to make a U substitution on that integral. Try to make a U substitution on that integral. U is tangent. It's really nice.
Probably go with just tangent.
Yeah, because that if you
Think about what's the derivative of tangent. And you see what's hanging right at the end there.
Yeah, the other one we're not going to make a new substitution for because there isn't the secant squared on that one to help us with our du. That one's just going to hang just like that. Okay, so it may take a little bit of time, but when you're thinking, you stare at it and you're like, well, wait a second. This is secant squared, and whose derivative is secant squared? Tangent. So when I take the derivative of tangent, I get secant squared. So for this integral, we'll leave this guy alone. If we let u be equal to tangent of x, then du is equal to, and remember it's a differential, is equal to
Secant squared x dx.
secant squared x dx. But look how nice this is set up for us. That's just our du, and this is part of our reduction formula. So then I would get the integral of u to the n minus 2. This much is my, it's all in the u substitution. U is tangent. Du, and then I've got just this guy hanging around. And nothing's going to happen to that guy. Now, can you do this integral? Can you do this integral? How do you, if you have the integral of u to the 7th, what do you do? If you have the integral of u to the 7th, what is it?
It's u to the 8th over 8.
U to the 8th over 8th. How about u to the 21st? It's
U to the 22nd over
No, so what about u to the n minus 2? What about u to the n minus 2?
U to the n minus 1 over n minus 1.
Perfect, perfect. Now what's your name again?
Ben.
Ben, yeah, thanks, Ben. Do you guys agree? Do you guys agree? So what I want you to do is finish this, okay? Finish this, finish the integration and substitute back in.
Is the reason you don't add a C in the reduction formulas because you still have an interval?
It's because you still have an integral.
Okay.
Yeah, that's a good subtle thing to ask. And you do it too. That one's alone because the reduction still always has an integral in it. That's, nice. And that's your reduction. Okay, everybody can just cheat off of me. Did anybody else get that? Did anybody else get that? Okay, so this is our derivation. Cotangent works the same way. Cotangent works the same way. Did everybody understand? Does this make sense? Did you understand? And see, this is the hard part about you being in video land and me being here. I can't really hear you answer. Okay. Let's see. John. Like right now, John, you're in Southern Virginia. Okay, stand up again, stand up again, stand up again. Stretch, look at somebody and say, you know, it's gonna be nice to have a week off.
It's gonna be nice to have a week off.
How many people have so much crap that's due? I mean, how much stuff that's not, yeah, I mean, if you're like me, you know, I was just buried by this time of the semester. Okay, sit back down. Okay, write down the integral of sine to the n of x. Okay, so you're looking at the integral of sine to the n of x. How many people realize that ain't flashcards? Okay, so you don't have. So now you might be tempted to try to follow the same technique, pull off a sine squared, and then make a substitution with sine squared plus cosine squared equals 1. I'll just save you that half hour. I'll just save you that half hour. Okay, you actually have to use integration by parts on this one. You actually have to use integration by parts on this one. This is homework. This is homework. Okay, this is homework. Do you have that sheet with those 6 integration part by parts? I mean, those 6 reduction formulas on that thing? This is homework. So write this down. You derive, and that's you derive the reduction formula. That's at that bottom of that worksheet for the integral of sine to the n of x dx. I'll just start you off. Okay, now which one can you integrate? Which one can you integrate? Which one can you integrate? That one or that one? Because you're going to use integration by parts. Which one can you integrate? So this one, so this has got to be my u. Then my dv is going to be that. I'm leaving it here. You guys, well, I guess I'll do the du with you. Then du, you guys find du. You guys find du, and you find b. You guys, we'll kind of end at that point. Yeah, I think we've got to use chain rule too. But yeah, there's noticing power rule is the way to go. When you finish, cheat. Look off somebody. Declan, I'll look off you. You're differentiating this, so your n minus one comes down, then you have n minus two. And then you use chain rule, because that's actually raised to that, so you
Yeah.
need the derivative of that sign outside also.
Oh, yeah,
Because that function's pregnant. Nice. Yeah, the derivative sign is cosine, positive cosine, that's, and then it's a differential, so you just throw the x over to the other side.
I don't know.
You guys still sit in the same seats, that's so funny. It's- Okay, which one's the easier, getting the du or getting the v? Getting the du or getting the v?
V.
I think the v also, because I mean, I just integrate this. You're right, it's negative. Whose function's derivative is sine? Negative cosine, sorry. So this would be, my brain, negative cosine of x. The derivative of cosine is slash negative sine, so we get that. Here you've got to use power rule. This is like sine to the 8th. Okay, so we take the derivative, the n minus 1 drops in front. Now, do we add or subtract? This is tough. Subtract, and we always got to remember these things. Minus 2, because n minus 1 more is minus 2. And you're tempted to end there, but then you remember, oh crap, I've got to use what rule? Chain rule. What's the derivative of sine? Cosine of x dx. Okay, now are you set up for your integration by parts? Are you set up for your integration? Don't do it. This is homework. I mean, we're just starting here. Okay, now I'm going to give you some hints. Be very careful with your signs. Be very careful because the derivatives keep switching. So hint 1, careful with signs. Hint two, you're going to need the apple tray, meaning that somewhere along the way you're going to get another thing that has a sign to the end, and you're going to take it over and join this. The third trick is that someplace you're going to want to use that sine squared plus cosine squared is equal to sine squared plus cosine squared is equal to 1. So those are the 3 tricks, and this is very similar to what we did with the secant one. So this is for what? Homework. This is for homework. Okay, stand up again. Okay, look at somebody and say, do your homework in section 7-2.
Do your homework in section 7.
Do your homework in section 7-2. Can you imagine like me seeing that, what the horror of that must be? Okay, stretch. Okay, sit back down. Well, I'm so glad none of you guys are going any place nice. I don't have to be stuck in Harrisonburg. Are you going to be at home the whole time? Okay. Yeah, okay, so I guess I better tell you a story, because we're going to start a new section, so I need your brain to... Let me tell you a story about my brother Doug, okay? Did I tell you about the time my brother Doug, what can I tell you, which one? I told you about the time he set the spanking record, right? Did I tell you about the time when he set the spanking record at the Christian middle school?
No.
Are you sure I didn't tell you about this? Okay, so yeah, my brother was like in 5th grade. The high school was attached to the middle school. This was Mansfield Christian. I probably shouldn't give the name. And this is in the 70s when you could whip children, okay? And so they had records of the number of swats, the worst offense ever. This is such a distorted time of life. And news came up to the high school that my brother had set the record, that he'd gotten 19 swats in a row. And I was like, holy crap, what did he do? And it didn't shock me. But then I found out they had to shutter the middle school for 2 days. They had to shut down the middle school for 2 days. He had taken a can of paint and thrown it into the school's furnace.
Oh my god.
And they had to have the whole school fumigated. And had all but ruined the furnace. So, I was like, okay, it just hit me, and I just sat there and I'm like, he's such an idiot. But about 2 or 3 years ago, now I'm 60, so he's probably 57. I just started asking him, so Doug, there's one question I've got. How did you ever get down into the basement where the furnace was and have access to a can of paint to throw it in? You were in school, and at the time it didn't register. He goes, well, you see, I was a crossing guard. They made me a crossing guard. I'm like, they made you a crossing guard? He goes, yeah, they thought giving me responsibility would make me grow up and mature and be, and that I would rise to the occasion. Okay, so I go, okay, so that's the way you got it. He goes, yeah, we'd go hang our thing, and that was right at the entrance to the basement. So I just hung my thing up and went to the basement. And then I'm like, well, how did they catch you? He goes, this is where I was dumb. He goes, me and my other friend, who was also in on this, we decided once we were down there to get a hammer and bang all the badges on all of the crossing guards and beat them. But we only left 2 of them unbeaten, and that was mine and his. I'm just like, okay, never mind. Okay, stand up again, stand up again. Okay, stretch again. This is the way you're going to feel. Okay, this is the way you're going to feel. It's going to feel like it's full of paint. The room's going to feel like it's full of paint. Okay, sit back down. This section is called trig substitution. Say that.
Trig substitution.
Okay, what do you think it involves? I mean, if you just had to look at the name, what do you think it involves?
Substituting trig.
Yeah, substitution with trig function. Now guys, I like this section, and in general, students at the very beginning panic, and they feel like they can't do it. And then as they get more used to it, they start saying, this starts, I think, becoming one of the funner sections. Let me just give you an example. If I gave you this, could you do that integral? Could you do that integral? Think about it, stare at it. Could you do that integral? Yes, I mean, if you're thinking about it, you're like, okay, it takes a little bit, but you're like, hey, that's just a flashcard. It's arc sine. It's sine inverse of x. Now look at that one, stare at that one. If you were staring at that, you're like, could I do that integral? Could I do that integral? You look at it, you stare at it, it's not flashcard.
You could.
What would you do?
Well, I mean, if you wanted to, you could do x times 1 over square root of 1 minus x squared, and that's just, the integral of x and then the integral of arc sine.
Yeah, you got to be a little careful with that. You can't break up the integral where you take it an integral times an integral.
Okay.
But I like where I.
You could try a U sub.
U sub, what might let U be?
1 minus x squared, because then your GU is negative 2x dx.
Does this make sense? Does this sound good? I mean, does that sound like, and so yeah, you could hit this one, you could get this one, making a U substitution. Here's one you're gonna stare at. I mean, and I'm just gonna not let you go through it. I'm not gonna let you think, you start running through your techniques, you don't wanna use integration by parts. It might be a little tempting, but no, it's not gonna lead. How many people look up there and say, that's not powers of trig functions? Okay, how many people do not see sines and cosines? Okay, how many people do not see secants and tangents? So you know that section 7.2 is off. Integration by parts, I'm just letting you know, is not gonna work. And so that's where this comes in, this next integration technique, and what's it called again? Trig substitution. Okay, so tell somebody to wake up. Okay, good. I'm going to give you the basic form first. This involves integrals where U substitution fails, and it's not a flashcard, where you have things that look like this. The square root of x squared minus a squared, raised to some power, it doesn't really matter. The square root of x squared plus a squared, this would be like a type 1, this would be like a type 2, and this would be like a type 3, a squared minus x squared. Whenever you have things where U substitution fails, but you have things that either square roots or these things raised to some power. I mean, it could be x squared minus a squared. Raised to some power, and this might still be a technique that would work. Okay, now again, it's called trig substitution. And I'm not sure anybody would quite, I don't know, I think students will learn if I talk like that. Okay, boys and girls. Crap, I'm on video. Okay, boys and girls, now listen. I'm not sure anybody would get this. So, it'll make more sense after we do some stuff. But when they are of the form
X squared minus
a squared, the substitution is read x equals a sine theta. When they're x squared plus a squared, now you try to think. This is a big stretch, and I can't do this voice much longer. But what might you guess the substitution might be?
Might be a cosine theta.
I like that idea, but no. Think of the inverse functions, those inverse ones that a tangent theta. Sorry, I can't keep doing this. Why am I videoing myself? Okay. What about this one? What about this one? I know this is hard. But if you think about, like, if you have the integral of 1 over the square root of 1 minus x squared, you just said, bam, that is, I guess not so bam, okay? The integral of 1 over the square root of x squared minus 1 is, 1 minus x squared. Arc sine, 1 over x squared plus 1, arctan, and that's kind of my read on these, okay? And then if you do, oh crap. This is sine. Okay. X squared minus 1, I'm not even following my own reads, okay? X squared minus 1, the integral of the square root of, well, it's 1 over x times the square root of x squared minus 1 is secant, and so that's where I get my reads on these things.
So does it make a difference if the x squared is in front of the a squared or Or like if it's x squared minus a squared.
It does, because the domain would be different. I know this sounds, Dr. One, don't speak of such things like domain. Okay, we don't ever want what? We don't ever want what under a square root? A negative. If we're gonna stay in the real number system, it's fine. Very useful stuff, negative square roots, just not in the real number system. You know, so if you're looking at like the square root of x squared minus 49 versus the square root of 49 minus x squared, their domains are just the opposite. Like here, you don't ever want to get beyond 7, either -7 or 7, because you put an 8, you know, negative. And here it's just the opposite. Here's just the opposite. You don't ever want to get inside. If you use a 1, you're negative. Beyond the 7 and -7. So they are slightly different, even though it's tempting to not think that way. Okay, so if I looked at this integral that we couldn't do, is it type 1? And I guess I'm an idiot. I really want it this way. I'll write it again that way. Is it type 1, type 2, or type 3? And I just made it harder. Is it type 1, type 2, or type 3?
Type 1.
It's type 1. And so this is what we want to do. Now, guys, I'm not even sure, when I look at the clock, we're actually going to be able to do this integral today. I'm not even sure we're going to be actually able to do the integral today. I just want to walk through what we would do with a type 1. And to do this, I need your brains turned on. So what I want you to do is stand up, stand up, stand up, stand up, stand up. Even though there's only like 15, 20 minutes, okay, what I want you to do right now is I want you to do some jumping jacks. Do some jumping jacks. We're almost to spring breaks. Jumping jacks, jumping jacks. You better be jumping and jacking at home. This is free exercise. Okay, sit back down, sit back down. Now turn your brains on. Say brain on.
Brain on.
Okay. You must remember your right triangle trig. Trig is your friend. Okay. Now, if I think about my right triangle, and I'm just going to use theta, that base angle theta, that means it's a, help me, that means it's a right triangle, okay. This is the what? Hypotenuse. As far as this angle is concerned, this would be the adjacent or the opposite side. Doesn't it kind of make sense? I mean, you're like, oh, it's part of the side making up the angle, and then that only leaves this to be the opposite side. Okay, now at home and here, I want you guys to write down the 6 trigonometric relations, identities for sine, cosine, tangent, cotangent, secant, and cosecant for that right triangle, because you're going to want these fresh. You can do it. In terms of opposite, hypotenuse, and adjacent, I want you guys to write down the 6 identities. Make your teachers proud. You better be doing this. I should ask to see your notes. Okay, for sake of time, sine theta would be equal to, I'll keep going, sine theta will be equal to,
Opposite over hypotenuse.
opposite over hypotenuse, thanks, Declan. Cosine theta, Ben.
Adjacent over hypotenuse.
Tangent theta.
Opposite over adjacent.
Opposite over adjacent. Cosine theta. Cosecant theta, cosecant theta.
Hypotenuse over opposite.
Hypotenuse over opposite. Thank you. Secant theta.
Hypotenuse over adjacent.
Cotangent theta, cotangent theta.
Adjacent over opposite.
Is this coming back? Is this coming back? Is this coming back? Okay, so now do you have these in your brain? Normally I jump to the other board there, but I'm teaching to a camera too. Okay, so now, if I was thinking about, I guess I'm just gonna work it out with the A first. I'm gonna work it out with the A first. If I'm in type 1, then x is equal to a sine theta. Solve for sine theta. Solve for sine theta. Okay, now draw a right triangle and put theta as that base angle. Draw a right triangle and put theta as that base angle. Okay. Now I should just have you cheat. But I think for time I will do it too. Sine theta, so you got sine theta was equal to x over a. Then what did I ask you to do?
Draw a right triangle.
Draw a right
as the
triangle.
base angle.
Okay, now sine theta, and I know that sounds dumb. We're just reading. Sine theta is x over a. Sine theta is also equal to
Opposite over hypotenuse.
opposite over hypotenuse. Now here's the thing, and I guess guys, this is when I don't care. You guys didn't come, they did. I'm jumping to this board. It's not that important. It doesn't matter. And guys, all I'm doing is drawing a bunch of triangles, all right triangles, kind of. Okay, all right triangles. Some bigger, some smaller, but they all have this base angle theta. They all have this base. These triangles are similar, so they're all going to have the exact same sine of theta. They're all going to have the exact same sine of theta. It doesn't matter the size of the right triangle. As long as the base angle is theta, the sine's always going to be the same in each one of those. So if I'm thinking about looking at this, who's in the hypotenuse location? Who's in the hypotenuse location? Does this make sense? I mean, if you're looking at this would be A, and then where would X go? Where would X go?
Opposite.
In the opposite side. Now, because of the Pythagorean theorem, you can find the adjacent side. You've got two of the sides. So do that. Do that. And when you're done, when you do find that side, cheat, look off somebody else, see if you got the same adjacent side. See, it's gonna be a little harder for you, but see if you got the same adjacent side as somebody else. Yeah, a squared plus b squared equals c squared. Yes, so what do you need to do? Oh yeah, I love the idea, then we can't, the square root of a squared minus x squared isn't a minus x. You just kind of have to leave it as the square root of a
Okay.
squared minus x squared. And so I guess now, I'll just call this right here C. I guess I should call it whatever, something not like our regular thing. I'm just gonna call it smiley face. By the Pythagorean theorem, I know that
Smiley face.
squared plus x squared is
A
a squared. I wanna find smiley face. We're all on the same page, we're all on the same page. I get smiley face squared by itself. And I get,
A squared minus x squared.
now do we see an a squared minus x squared kind of thing in this integral right here?
Mhm.
Not only that, smiley face is equal to the square root of
A squared minus
a squared minus x squared. Now it's tempting to start thinking like, okay, well, the square root of a plus b is the square root of a plus the square root of b, but no, you can only distribute multiplication. You can only distribute multiplication. So we just found smiley face to be the square root of a squared minus x squared. We just found smiley face to be the square root of a squared minus x squared. Okay. Are you still with me? Are you still with me? Are you still with me? Okay. Well, I know that cosine of theta, now that I've got this triangle figured out, cosine of theta would be equal to, looking at our right triangle, cosine of theta would be
A
equal to,
squared, or square root of a squared minus x squared over a.
You guys wrote down those identities, we got a right triangle, the cosine would be the adjacent side over the hypotenuse.
Wait, isn't it flipped? A squared minus x squared.
Thanks, Ben. Oh, how do you guys want anything from me? I hope this is at least readable from the board. Hope there's not too much of it. Divided by A, adjacent over hypotenuse. Now, that would imply that the square root of a squared minus x squared is equal to, now just solve it guys, just solve it. You got this fraction, solve it, get it all by itself. What would that be equal to? What would that be equal to? Write it down. And what did you get? What did you get? A cosine theta, is that what you guys got? So I'll write down the same thing. All I'm not doing anything tricky, guys. I'm just multiplying both sides by A. Now we're going to use this right triangle in the end, so I don't want to erase it. But I do kind of want to get you guys a flashcard. When you see something like this, this will be our first flashcard for this section. Okay, when just on the front of the flashcard, the only thing I want is for you guys to have the square root of a squared minus x squared. That's the only thing, that's the only trigger you get. That's the front. On the back, you're gonna put three things. On the back, you're gonna put three things. This is the back. Now let's see what you learned. Do not look anywhere else at the board. Look me right in the eyes. And you guys look me right in the eyes too. Austin, you better be looking. X equals, what's the substitution? A sine theta. Now, this is the next one. I want you to create the triangle, but I don't want you to have to go through this step every single time. I don't want you to have to go through this step every single time. I want you to immediately write down that the square root of a squared minus x squared, and what did we find it to be? I mean, when we went through the work of it, we only want to go through it once.
A cosine.
A cosine theta. And it's always gonna work something like this for every single one of these three types. This is the last one. This is the last one. dx. We're making, what's the name of this section again? So it's just like u sub. We're going to make a substitution. So we're going to need a differential also. dx, a is just a constant, would be equal to the derivative of this. If x is equal to this, dx would be equal to the derivative of this with respect to theta, d theta. A is just a constant. The derivative of sine is cosine. So dx is going to be equal to a cosine theta. But just like with u substitution, I need a d what over here? I need a d what? D theta, not du. Are you guys following? I mean, we'll pick up again after break with this. But I just want to look at this integral right here. I'm now going to erase this and show you how this substitution really makes this integral a little bit more tractable. Who's my a, first of all? Who's my a here? 1. So wherever I'd see this in my flashcard, in that case, I just have a 1. Are you with me? Are you with me? Okay, let's make the substitution. Making my trig substitution, x is,
a sine theta.
and so in this case it would just be sine theta. So then x squared would be
Sine squared theta.
perfect. And sine squared theta. Are you guys following so far? Are you following? Okay, the square root of 1 minus x squared. This is why we made the substitution. What does that end up from our flashcard being? Let's
That's
a cosine theta, but a is
1, so cosine theta.
so just cosine theta. Are you with me? Are you with me? Okay, now guys, this is the mistake, and let me just yell at these kids too. This is the mistake. Say that. This is the mistake every kid makes. Say that again.
This is the mistake every kid makes.
Now, do you want to be one of the every kids? Because we use the word mistake. I don't know quite how to do this. I mean, I almost I think I should like slap you. Psh, psh. When you make the mistake, when I see you making a mistake, I just want to give it back like a quiz, and then I want to go psh, psh, because I think at that moment it would stick enough. So do this. Psh, 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 psh. Okay, again. You've got to substitute for the damn dx. Say that.
You've got to substitute.
Because kids don't do that. I don't know what happens. They just leave it as a dx. And I'm like, what the hell happened? It's a substitution, just like u substitution. You must substitute for the dx. Say that.
You must substitute.
Now use the word I.
I
must substitute for the dx.
I must substitute.
What is dx equal to?
A cosine theta d theta.
Okay, so even though you guys promised me you would do this, there will be a number of you, especially you in Videoland, that on your test you won't do this, and I'll be like, what else can I do? But I've had them beat themselves. So if I do that, if I substitute for dx, it's going to be a, and my a here is
1.
thanks. Okay, so it would be cosine theta, and I'm not done. You guys are going to help me.
D theta.
D theta. Now, good substitution in the end or bad substitution? And we made a good move or a bad move?
Very good.
If I do this, don't those guys cancel?
Yeah.
And isn't the integral of sine squared a flashcard?
Yeah.
Yeah, it is. It's 1/2 x minus 1/2 cosine x sine x plus c. But notice we ain't got an x, we've got a theta. Theta minus 1/2 cosine theta sine theta plus c. And we're really proud of ourselves at this moment. We're really proud of ourselves. But we're not done. We're not done, okay? But class is over. But class is over. so this is like a horrible thing. It's like our Netflix season ending, okay? It's like them stopping Ozark on episode 7, and then you're like gotta wait for like weeks to find out what happens.
They made a part 1 of the final season, and then they haven't come out with a part 2.
Yeah, my daughter worked on the part 2.
Does that mean you get to see it before everybody else?
No, it doesn't mean I get to see it before anybody else. She got people coffee and went to get big donuts up for people, so, and I made that, I just said that on my video. Okay, sorry. Okay, I don't think I did a copyright violation this time, which is my typical move. You guys have a wonderful spring break. Say that.
You guys have a wonderful spring break.
Okay, now I used to say 81 on 81 is reckless op, but they changed that law. Okay, 85, 86 on 81 is reckless op. Say that.
86 on
81 is reckless drive.
Okay, I need you back. I need to beat on you. I need to beat on you more. Have a wonderful break, guys. Have a wonderful break. Oh, I'm hoping after you get back, I can get rid of this mask.
So I'm pretty sure that for the WebAssign, you assign just the trace of WebAssign.
Oh, no.
Because I tried to work on it yesterday, I went to the SMLC and they basically taught me trace of. Because, yeah.
Oh, no.
It says 7.3 on it.
Oh, does it say 7.3?
Yeah. Because, I
Okay.
mean, it was the same thing, and I mean, I
Oh,
started.
all right, Ben, yeah, thanks. I'll send out.
Okay.
I'll just cancel that website. I thought I was hitting 7.2.
Because I tried to